analyzing. We're going to analyze our data using
Thank you. My name is Shadrach Gambi.
Thank you. My name is Shadrach Gambi. Before starting analyzing the data, we first needed to install some packages in our studio. You type the code, install packages, read X1, and the library read X1 and execute. After executing, then you copy the path where there is dataset, and then you proceed to summary statistics. After running summary statistics, this is our output. We have minimum age, which is 18. First quartile, that means to say 20% of
Age of students.
they are of age 20.25, and our mean age is 22. Our maximum age of students is 36. From there, we proceed to other tasks. Thank you. There, we proceed to summary statistics. We write the code summary data. After executing this code, you have this output. This output, if you can see, it shows that we have the 18, which is our minimum age of students, and then we have first quartile, which is 20.25. This shows that 20% of students have the age of not more than 20. Then we have our mean age, which is 2.31, and we have our 31 quartile of 75%, which shows that 75% of students have the age of 23. And then we have our maximum age of student is 36. From there, we proceed to the second task. But before there, we have to know that there are 159 observations in our dataset.
So after
summarizing statistics, then we have our second task, which is to create our paragraph. And before running the code that will give us the output for paragraph, we need to install it. As well, the package, we can write the code install packages, ggplot2 is storing the packages, and then with our library, ggplot. And from there, we will write the code which will produce the output of our paragraph. So we can see this is our output for the paragraph. Our x-axis is the age, and the x-axis is the gender, and our y-axis is age. Then we proceed to the other, to creating the heat map.
So
to create a heat map, we first write the code df heat map right as data frame. From there, after writing this code, we execute it, and then write the code ggplot. This is the code that we will produce the heat map. So if we look at the So after writing the code, ggplot, df heatmap, x-axis program, y-axis age, and then the number of students. This is our output for heatmap. We can see that the BATE and the button extension. So from there, we proceed to plot the keynote density.
So we write this code,
ggplot dataset, and then we have our x-axis, which is age, and then our y-axis is density. From there, after writing this code and executing it, we have this output. You can see, if you can see,
shows
a lot of concentration on in females. As you can see, there is high PG side of females, and from there we proceeded to box plotting. So to run a box plot, we needed to write this code and execute it. We write the g plot data gender, y-axis age, fill gender, and then we have the x-axis which is gender and y-axis which is age. From writing this code, then we execute it. We have this output. This is our box plot. So looking at our output, the curve to each gender shows the probability density of ages. A taller peak indicates a higher concentration of students at that particular age. Then in central tendency, the center of each curve where the peak is highest indicates the most common age and age. Once again, my name is Chandrick Gamble. So after doing summary statistics, now
OLS analysis.
So
the first step is to
do installation of packages by using install packages Heaven as our code. Then we execute the code. After executing that code, we go to library Heaven. Then after that, we want to input our data into R by using a code wage one less than read data, then path where our data is located. Now for modeling, we proceed by executing a code model less than in wage education plus experience data wage one. After that, we do a summary of model in order to check our coefficients. As you can see, this output says estimation and standard deviation as well as p-values. So, by the way, my name is Mishek Man. From here, my friend will take from here by doing the diagnostic test. Thank you. Once again, my name is Chad Kambi. We proceed by running diagnostic test. Issues to do it in multicollinearity, elasticity, and the normality of residues. So here we will have first to install some packages to run the diagnostic test. After installing these packages using these commands, then we write the code library, ARM test, and the library card. Therefore, from there we will check for heteroscedasticity using Bush pattern testing. From there, we proceed to normality of residues, and then we have the visual representation of these residues. If you can see here, we have our y-axis, which is standardized residues, and then we have theoretical quantiles of wedge and.
So from there, we look at
multicollinearity, which we write the code, print variance expression pattern. Then from there, we have the summary of diagnostic testing. We compare this at significance level, which is 0.05. So if calculated p-value is less than 0.05, then we So this is our summary of the diagnostic test results. So the p-value of this, which is if it's less than 0.05, then we see that there is evidence of heteroscedasticity, and for normality of residues, if the p-value is also less than 0.05, then we can say that there is no normal distribution of residues, as well as if you can see at 0.05 comparing to the calculated one, we can see that there is no evidence of multicollinearity. So from there, we proceed to running logistic regression. So to run for
logic,
logic,
first of all, we are going to use
a web use data. But before this, we are going to install some packages, which is install packages lead x1. From there, we are going to execute that command, the library read x1. Now, in protection of data, we are going to use this code, data less than read x0 there for the path where our data is located. From there, we did the summary of data, as you can see from this output, where it shows a lot of some stuff, where even as you can check, what age, minimum age was 40, median was 23, and the maximum was 45. See, into the fitting of model, we used a code of
no age
plus less plus small.
After this
After this
code,
code, we did the summary of logic model, as you can see from here, this output, where it says coefficients, age, it says the increase in one year of a person led to a reduction by 0.03799 weight of the mother. So proceeding to check for
first of all, we need to install some packages as well, which says
install some packages as well, which says install packages margins as our code, then we execute. From there, we did the library margins. After that, we did the margins logic model to check the effect of each parameter.
So
this is our output.
So
from here we proceed to probe it more by using auto data. So first of all, we did the same installation of packages, install package heaven, as you can see. Then from there, we went by checking if our variables are either numerical or categorical. So we did this code autoforeign less than numerical autoforeign. So model fitting, we use a probit model by executing a code probit model less than the foreign price plus MPG weight. Now to check for the whole, we use a summary probit model. As you can see from here, the output as well, the coefficients, which says the increase in price by 1 unit leads to increase by 0.0. After that, we checked for margins effects as well. We installed the other packages as install packages margins as well, the library margins, the margins probit model. After that, summarize MFX to show this output, the effect of every parameter given. This marks the end of our data analysis section, where we have looked into state analysis, RSQ analysis, and state analysis. Thank you.